Hello friends, welcome back to my channel. So in this tutorial we'll look at this question: how do you solve this question? This is if you start off by making a u-sub by letting u to be equal to the 2 times the square root of x, things will play out nicely. So let's dive into that and see what happens. So I'm going to start off by letting u to be equal to 2 times the square root of x, right? So maybe we can square both sides, make things easier. Why not? U squared is equal to 4 times x. So we can now differentiate. That implies that x is equals to u squared over 4. So dx is going to be u over 2 du. That is differentiating u squared over 4. We get u over 2. So in place of dx, we can replace that with u over 2 du. What about the change in limits? When x is equals to 0, u is going to be equal to what? 2 times the square root of 0, that is 0. When x is equals to infinity, u is going to be 2 times the square root of infinity, which is infinity. So the limits actually will not change here. So now at this point, let's take our integral from the x world into the u world. So I is going to be the integral from 0 to infinity of 1 all over x is now what is the value of x here? X here is now u squared over 4. So that is u squared over 4 plus 1 plus 2 square root of x is going to be u. And what is dx? Dx is u over 2 du. That is from here. So this one simplifies to 1/2 is a constant. It can go in front. Integral from 0 to infinity of u divided by, you can simplify the denominator, which is u squared plus 4u plus 4. All this one divided by 4 du. And the 4 can become a numerator, so that is going to be 4u. So 1/2 the integral from 0 to infinity of 4u divided by u squared. Making a mistake here. This one is squared. I beg your pardon. This is squared, and the whole of this is squared. I'm sorry about that. So this one, I can now clean this because we are making a mistake. So this 4 squared is now 16, which becomes a numerator, which is 16u at the numerator, divided by u squared plus 4u plus 4. All this one squared du. And this one 16 is a constant. It can go in front, which becomes 16 over 2, which is 8 all the way in front. Integral from 0 to infinity of u divided by this u squared plus 4u plus 4 can also be written as u plus 2 all squared. And all this one is raised to the power 2 du. And that is 8, the integral from 0 to infinity of u divided by u plus 2 all raised to the power 4 du. Like this. So we can do another u-sub here. Why not? We can let k, let's say k to be equal to u plus 2. And the k is going to be equal to du. The change in limits, when u is equal to 0, k is going to be 0 plus 2, which is equal to 2. When u is equal to infinity, k is going to be equal to 0 plus infinity plus 2, which is equal to infinity. So our limits will change from 2 to infinity. Now we can take our integral from the u world into the k world. So I is going to be 8 times the integral from 2 now to infinity of u. Well, what is u? U here can be expressed as what? U here can be expressed as k minus 2. That is from our k substitution. So that is going to be k minus 2 divided by u plus 2 is k. That is k raised to the power 4. And du is the same as dk. So that is going to be 8 times the integral from 2 to infinity. And this one can be split now into k over k raised to the power 4 dk minus the integral from 2 to infinity of 2 over k raised to the power 4 dk, like that. So I is going to be 8, the integral from 2 to infinity of k raised to the power negative 3, that is this one, dk, minus the integral from 2 to infinity 2 is a constant, can come out here, and that would be k raised to the power negative 4 dk. So I is going to be 8 times what? This one is k raised to the power negative 3 plus 1 divided by negative 3 plus 1. And that is really what? Negative 1 all over 2k squared, right? From 2 to infinity. Minus 2. Integrating this one, that is k raised to the power negative 4 plus 1 over negative 4 plus 1. That is negative 1 all over 3k raised to the power 3. Like this, from 2 to infinity. So we can now put them together really. So this one is going to be multiplying 8 through, that is going to be negative 4 all over k squared. And this is positive times 8, that is going to be positive 16 over 3 times 1 over k raised to the power 3, right? This is how this can be simplified, and you are integrating that from 2 to infinity. Now we can take our limits really. So this is the limit as, let's say, k approaches infinity of negative 4 all over k squared plus 16 over 3 times 1 over k raised to the power 3. This is the upper limit minus, you plug in your lower limit, that is going to be negative 4 all over 2 raised to the power 2 plus 16 over 3 times 1 all over k raised to the power 2 raised to the power 3. So I is going to be, as k is approaching infinity, this one is going to be approaching 0, this one is going to be approaching 0. So the upper limit is really 0 minus, this one here is like 4, negative 4 over 4 plus, this is 16 all over 24, because 2 raised to the power 3 is 8, 8 times 3 is 24. And that simplifies to what? This one is negative 1. That's going to be 1 minus 16 over 24. That is going to be 2 over 3, right? And that reduces to 1 over 3. I'm sorry. This is 1 over 3. So therefore, our integral, which is the integral from 0 to infinity of 1 all over x plus 1 plus 2 square root of x, all this 1 squared dx. This one evaluates to 1 over 3. This is by just using pure U-substitution. So if you really find this helpful, make sure to smash the subscribe button for more engaging content from Calculus Diaries. I thank you so much, and I will see you in the next one. Bye bye.